Hello, I am Brit Salakino, and for today I will discuss about the principles of sampling, the advantages of sampling, and the types of sampling, which will focus on the non-probability sampling, as well as the types of non-probability sampling. So first, I will discuss to you about the principles of sampling, in which Bradfield and Murdoch have been was able to identify three principles of sampling. So the first one is appraisals, which involve sampling, are estimates and predictions only. So we already know that appraisals refer to the process of assessing someone. So naging din na nga, assessing someone kuno, which involves sampling, are estimates and predictions only. So the second principle of sampling is estimates that based on sampling are least accurate when the sample is a small proportion of the whole and when the sample is not representative. So we all know that sample refers to our respondents, or sample means the proportion of a population taken as the subject of our study. So mo na siya ang atong respondents. They are our subjects. Next is uh, um, we can call the sample is a representative when it is taken from all sections or groups of a population in equal proportions. So for example, you are studying the overall kanang students in Bisomain, and you are just getting a small proportion of the whole population of Biso. So it is least accurate ang imong findings. Why? Because gamay ra nga proportion imong gikuha sa whole nga population sa Baisu. And what else? Especially when your samples are not representative. So when can we say that our sample is representative? It is when we take a proportion in an equal manner, no? Tanang every section sa every courses, every section, every classroom sa Bisomain, the same proportion ang imuhang kwaon nga samples. Like for example, all the 3-person, tulo ka taon ay of 4 persons, duha ka bayi, duha ka laki, for all the sections, all the classrooms, and all the courses of Bisomain. It will only be accurate when your sample depends on the representativeness of the sample you have chosen. Okay, for the third principle of sampling, which Bradfield and Murdoch identified, is that sampling may either be categorical or temporal. So, sample can only be categorical when it is taken proportionally from all the categories or groups. So, that's what I have stated lately on the second principle, proportional jud ang gikan sa tanang categories, no, sa tanang group. For example, one group Bohol Island State University students, and you are getting all the same proportion from all the categories of the courses of Bohol Island State University. Sampling is temporal when the sample is in terms of time, in terms, as for example kanang sa hospital, no, the pulse of a patient is taken every 10 minutes, so it is temporal. Why? Because it involves time. Okay, so that would be all for the principles of sampling, and now I will discuss to you about the disadvantages of sampling, no. There are 4 disadvantages of sampling or defective sampling. So the first one is that if sampling is biased or not representative or too small, the conclusion may not be valid and reliable. Why? Because you are getting a biased sampling. You are not getting the representative. For example, sa katong sa principles of sampling kaganina, mabias ang imong mahimong dili reliable o dili valid ang imong conclusion kung bias ang imong pagpili sa sample. Pilion nimo na siya nga kanang respondent sa imong study tungod kay friend rin nimo, then it will be valid. It wouldn't be valid, or it will be unreliable. Why? Because you are not getting the whole proportion, you are not getting the equal proportion of all the students in Bohol Island State University, Maine. No? Second would be, in research, the respondents to a study must have a common characteristic which is the basis of the study. So, what are some examples of these common characteristics among respondents? For example, kato kuan ganina, giingon ninyo ganina nga sa college students kay since Vice Bohol Island State University main man, so imuhang yung mga respondents sana is all from the college level and all from the Bohol Island State University Maine. So what are the common characteristic of them? Muna siya, ang common characteristic ana is all the samples or all the respondents are a college level. So that's what it means sa your sample must have a common characteristic. Okay, so if some kanang high school students mahimong sample atong imuhang study, then the conclusion may become erroneous. Okay? So the third is, if the population is very large and there are many sections and subsections, the sampling procedures may become very complicated. No? For example, ang imuhang population, no, ang imuhang kanang napili is the whole population of Bohol. Imagine, like, maglisod pa ka og kanang alphabetical, maglisod pa kag assign of numbers in each because kanang mas madugay ka. Why? Because mabtan pagpila ka adlaw. Ay ka makalista, makakuha sa tanan nga kanang name sa population, kanang mga nagpuyo sa Bohol. Okay, so isa na siya sa disadvantage because kanang magkuan pa man ka, kanang taas pa kayo og process and magsuwat pa ka og names nila in a piece of paper, ano mo pang lukoton ay mong i-place sa raffle box. So it is very risky, it is very complicated when you are choosing a large amount of population. And the last disadvantage is that if the researcher does not possess the necessary skill and technical know-how in sampling procedure, the sampling may become biased and unrepresentative. So for example, you are doing a study and then kanang sa imong pagpili, you don't know how to choose your respondents, kanang basta-basta ra kag pili, so kay friend mo siya, imo na siyang gipili. You do not possess the technical know-how, or you do not possess a necessary skill, no? In sampling procedure, no, kay naman tilay di ba nga there are different kanang kinds and types of sampling, di ba? If wala ka kahibaw-an na, then your study would become biased or unrepresentative. Kay magjama-jama naman lang kagpili mong sample as long as na kay respondents na maka-answer sa imuhang study. So it will really become biased, especially ang mga tao nga imong napili nga paansiron sa imuhang study does not know about your study. Dili mo fit ana nga study nimo, which is why it will become biased, and that would become a disadvantage because you are not proving dili jud siya ingon nga valid nga proven jud ang imong study because kay mao lagi to, you don't know how to get your respondents. So there are two general types of sampling. The first one is probability sampling, which in which the sample is a proportion or a certain percent of a population, and such sample mo na siya ang napili or selected from the populations by means of what? Some systematic way in which every element tanang element sa population na ay chance na mahimong appeal sa sample. For example, the whole bisomain, you're getting the whole proportion mo siya, you're getting the whole kanang the equal proportion jud sa tanan nga courses, sa tanan nga sections. So mahimo siyang equal tungod kay nga naman it is a probability because you are getting the whole proportion. So every courses has a chance na ma-appeal jud sa nga mahimong sample nimo. That is what probability sampling means. While non-probability sampling, or the second general type of sampling, is the non-probability sampling. So it is the sample in which the sample is not a proportion of the population and there is no system in selecting the sample. So, wala sistema nga gisunod sa pagpilig sample. Basta na ka, pintot-pintot, kani siya, appeal, kana siya, appeal. So, that is non-probability sampling. In a sense, na wala siya gi-follow nga systematic nga selecting. Okay? So, there are also types of non-probability sampling. So, there are 3 types of non-probability sampling. The first one is accidental sampling, Kota sampling, and the convenience sampling. So, first is the accidental sampling. From the word itself, accidental, no? Kanang you might the researcher might get or might choose a sample in an accident manner, like nag-meet sila accidentally sa street na pwede na niya himuon nga sample tungod kay we are not following a systematic way of selecting of samples in non-probability sampling. So, in research, every section of the population being studied must be proportionally represented in the sample. So, accidental sampling is resorted to only when there is no other alternative. So, when do we use this kind of sampling? Only when no other choice, no? When there is no other alternative in sa ato ang sampling. Mura ni siya tungod kay wala na lang tayo choice, so talang choice. Sige, kanina lang sa accidental sampling. The next one is the Kota sampling. Now, what is Kota sampling? So, in this type of sampling, as the word itself, no, from the word Kota, what does it mean by Kota? It means na na-specified number of persons of a certain types are included in the sample. Like, for example, when you are studying the reactions of the people towards a certain issue to be determined, and as such, cross-section of the population must be involved. No? It might be decided na 10 ka teachers apil ana, 20 ka in a quota of 20 ka students, in a quota of 15 ka lawyers, maapil ana siya. So it is kanang na specified nga number of persons in a certain type of tao nga maapil ana sa imuhang sample. But the advantage of this one is Kota sampling. The advantage of Kota sampling over the accidental sampling is that many sectors sa population are represented. So, daghang sectors sa population, maapil sila sa sample. However, ang iyang representativeness is doubtful. Why? Because there is no proportional representation and there are no guidelines in the selection of respondents. Wala ka naman, imuharang, wala ka kanang guidelines sa pagpili sa respondents ba mo halang kung pili gusto nimo mo apil pila ka teacher mo gusto mo apil pwede ra nimo ipa-apil, no? There is no guidelines, no equal proportion. That is why wala siya representativeness. Okay? And another danger also for Kota sampling is that the perception of the minority may become typical in the findings. Why? Tungod kay, for example, majority of the sampling pananglitan are professionals who are in the minority. Mas gamay ang number of professionals compared to the number of non-professionals, pero mas daghan imong gipili ng mga professionals compared sa non-professional, which is why mahimo siyang danger. Why? Tungod kay dili ang majority jud sa whole population nimo nakuha. Kaya naman tungod kay ang majority ra sa professionals sa imong nakuha nga kanang nga feedbacks nga response na, so it will become a danger. So Kota sampling may be used only when any of the more desirable types of sampling will not do. Kung ano pa ni siya kanang choice pa ni siya, no? May magamit ni siya kung any kuno sa desirable type of sampling will not do. So you will use Kota sampling. And the last type of non-probability sampling is the convenience sampling. So convenience sampling kuno is a process of picking out people in the most convenient and fastest way to immediately get their reactions to a certain hot and controversial issue. So for example, you are getting you want to get the views of the people, no, regarding the price of the gasoline, so the raising of price of gasoline. So you think that the most convenient and fastest way to reaching out people is by the telephone, no, to be able to interview them at once, no, kanang interview kanina, interview kadayon ba, so manawag ka through telephone. So the interviewer, of course, will contact those people who have telephones. Alangan naman ito sila mo contact, diba, sa may telepono, to get the reactions about the issue at hand, no? So ang kanisya, this type of sampling is certainly biased and not representative, considering that the people nga naay telephone are a class by themselves, and so ang ilang opinion or ilang views are not considered as the views of the people. Why? Because they have class, no? They are classy, diba? Sa unang panahon, if you have a telephone, kana you belong to the class A, ganana. So dili siya matawag nga view of the people. Kaya ano man, if you interview them about the raising of the gasoline, there might be a chance nga kanang wala lang nila tungkol kay ano man, they belong to the class A. No, how about those who are under, no, are kanang under their class, no, like nana sa mga lower classes, no? How about their views, no? Dili makuha jud ilang view. Tungod kay ano man, the researcher have chosen those who are in high class than those in the lower, than those who are in the lower ones. So it is not a views of the people, it is just a view of the classy people. Yung ana siguro ang mahitabo, no? So it should be noted that even in ordinary data gathering and research, interviews can also be conducted through the telephone, provided that those interviewed by the telephone are only among those who are properly selected to be included in the sample. So it only happens that these people have telephones. Okay, so I guess you all have understood about the types of non-probability sampling, which are the accidental sampling, the Kota sampling, and the convenience sampling. So I guess that ends my report, and I hope you guys have learned something.
So hi, it's me again. So for today, I shall be discussing to you the types of probability sampling. And the first one we have here is a pure random sampling. So as you can see on your screen, pure random sampling is also known as unrestricted random sampling and or the lottery or raffle type of sampling. So why is this so? Well, it is because in pure random sampling, everyone in the population is given the chance to be selected as a participants in the sample. And it is also called unrestricted because, like I've said earlier, everyone is given the chance regardless of their levels, their classes, their sections. So everyone is given the chance. And pure random sampling can be done through writing all the names of the people in the population and then randomly picking their names according to the desired sample size that you want to have in your study. Suppose, or for instance, you have a population is composed of 400 people, and then the percentage or the proportion that you only want to get is 20% of it. So 20% of 400 is 40. So at first you write all the 400 names. Each paper has a name on it. So meaning 400 papers with names of the people on the paper. And then you place all the papers you have written the names on inside a bowl or any container that you have. And after that, you randomly pick 40 names, since 40 is a 20% of 400. And after you have picked all those 40 names out from the bowl, then that's already your sample. Very easy, right? And the main advantage of this type of probability sampling, which is pure random sampling, is that it is easy to understand, and also it is very easy to apply. However, the main disadvantage of this type of probability sampling is that it is hard to use, and especially when your population is very large. So of course, it is also not economical, because you still have to have papers, and then you cut those papers into strips. You still have to write those names, so it needs effort. It needs effort to write all those names and to manually pick those names out from the bowl or any container that you have. And now we move on to the second type of probability sampling, which is a systematic sampling. So as you can see on your screen, systematic sampling is defined as a sampling technique in which every nth name in a list may be selected to be included in a sample. So this type of probability sampling, the systematic sampling, is used especially when your subjects are being listed in a logical manner. So examples of logical manner are alphabetical order and or house arrangements and house arrays. So there is a sample procedure there on your screen, so let's read it first. For instance, 20% of a population is a sample size. If 100% is divided by 20%, the answer is 5. Thus, every fifth name in the list or array is selected. However, there must be a random start. The researcher may run his finger down in the list and then stop. The number which his finger points to at this particular time is the random start number. So for example, a researcher runs his finger down on the list and then stops at number 13. Then number 13 is his random start. And since 5 is the n or nth name in that list, so the researcher will add 5 to the random start number, and so 13 plus 5 is equals to 18. So the first number is 13 and the next number is 18, and so on and so forth. So 18 plus 5 is equals to 23. So 13, 18, and 23 are the numbers, and then so on and so forth. 23 plus 5 is equals to 28. 28 plus 5 is equals to 33, until the researcher reaches the desired sample in his study. So the main advantage of this type of probability sampling, the systematic sampling, is that it is more convenient, faster, and more economical than the pure random sampling. Since it is convenient, since the researcher won't have to write all those names, cut those papers into pieces, then manually pick those names included in the sample. And also, its main disadvantage is that the sample becomes biased if the persons in the list belong to a class by themselves, whereas the investigation requires that all sectors of the population are to be involved. So this is because, for example, your study includes the workers of a particular school. So when we say workers, they are being classified into teachers, security personnel, HR department, accounting department. So since in systematic sampling only the fifth name is being included, so what if um, all the fifth name in the list are coming from the accounting department, or coming from the teacher, from the faculty? So the study won't be able to get the desired result if the participants will only come from a single department or a single stratum. So that's the advantage of the systematic random sampling. So the third type of probability sampling is a stratified random sampling. So as you can see on your screen, stratified random sampling is being defined as the process of selecting randomly samples from different strata or groupings arranged either horizontally or vertically of a population used in the study. So when we say horizontal stratifications, these are stratifications having the same level or having the same characteristics. So for example, horizontal stratifications are sections in the same school grade or year. So as you can see on your screen, section 1, section 1, so all section 1s, those are all horizontal stratifications. And of course, sex such as males and females, while vertical stratifications, these are stratifications having different levels or vary in their characteristics. So examples of vertical stratifications are age, such as 7, 8, 9, 10 years old, grades in school such as grade 1, grade 2, grade 3, and economic status such as poor, average, rich, or etc. So as you can see on your screen, there is a stratified random sampling procedure. So let's read it first. So we have here, determine a common stratum or class which all the elements of a population belong. Then divide or group the elements of a population according to the characteristics inherent in the whole class or stratum that make the elements of a population different from one another. After stratification has been completed, apply either the pure random or systematic random sampling in the actual selection of the samples in every section or stratum, and the selection must be proportional, which means same percent is used in every section or class. So we have here a table to further illustrate the procedure in applying stratified random sampling in a study. So we have here the horizontal stratification, which is, for example, your study includes college students as your participants or your sample. So the characteristics that vary college students are, of course, the courses in which they are taking. So we have here education, commerce, and nursing. And also their curricular years. So we have here the first, second, third, and fourth year. We also have their sex, which are males and females. And we also have here the frequency. And as the procedure said a while ago, that the proportion must be the same. So we have here 20%. So for example, we have here 50 males in education, and 20% of 50 is 10. And in choosing these 10 people, we can use the pure random sampling, in which we list all the 50 names of the male education takers or education students, and list all their names and pick 10 names out from the bowl or any container. And in the female, we have 75 education students, and the 20% of 75 is 15. So we can use the pure random sampling and systematic random sampling as well. In the commerce, in the second year, we have 270 males, and the 20% of 270 is 54, and females having 380, and the 20% of 380 is 76. And in nursing, in the fourth year, we have 20 males, and 20% of 20 is 4, and 250 females, and that 20% of 250 is 50. We have here the total, which is the 813. So the total population of the college students is 4,064, and we only get 813 out from a 4,064 college students. So that is a stratified random sampling. I hope you understand. So moving on to the fourth type of probability sampling is superpositive sampling. So this sampling technique determines the target population, and the respondents involved in the study are chosen on the basis of their knowledge of the information desired. So in this type of probability sampling, participants must be chosen carefully, because their knowledge, the knowledge that they have, will really affect the result of the study, or the result that you want to have in your study. So for example, if your study has something to do or is related to laws, legal actions, republic acts, so you better choose lawyers as your participants or included in your sample. And of course, if your study is all about education, teaching techniques, then you better choose teachers as your participants. And same goes as well with those, same goes as well if your study is all about health, medicine, so you better choose nurses, doctors, and everyone else that work in the medical field or belong to the medical field. And in choosing your participants in purposive random sampling, you can use both pure random sampling and the systematic random sampling. However, if your participants belong to differentiated groups, so for example, your study is all about effectivity of teaching techniques, so teachers vary, of course, in their subjects of specialization. So there are math teachers, English teachers, science teachers, Filipino teachers, history teachers, ethics teachers, or whatsoever. And so since they are different, they teach different subjects. So you better use stratified random sampling. So for example, if it is a big school, if it's a large school, so it is possible to choose 20% from the math teachers, 20% from the English teachers, from the science teachers. So that's the concept of purposive sampling. I hope you understand the concept of purposive sampling. So the fifth type of probability sampling that we have here is the cluster sampling, or the multi-stage cluster sampling. So as you can see on your screen, this is used when the population is so big or the geographical area of the research is large. What we also have here is general procedure. So the general procedure is that to divide the area or population into clusters or blocks, and then within the final cluster apply any of the different methods of selecting a sample. So we also have here a sample study. Suppose the study is to be conducted to determine the standard of instruction in a certain region of the country in elementary schools, and given that there are 9 provinces and the proportion to be the sample is 20%. So we also have here the steps in applying the cluster sampling in a study. So the steps are: first, make a listing of the sampling units, the primary sampling units, which is the first clusters to be sampled, the secondary sampling units, which are the second clusters to be sampled within the primary sampling unit, and etc. So the second step that we have here is that 20% of 9 provinces is 1.8. So let's round it off to 2 provinces. Select these 2 provinces by either pure random sampling or systematic random sampling. So if you can see on your screen, there is an oval there. The oval is yellow. and we have P1 to P9. So P there stands for province, and there are 9 there. So we have 9 provinces to be represented in the oval. And say for example, a researcher was able to choose P5 and P8 as those 2 provinces. So by pure random sampling. So the researcher was able to choose those 2 provinces by pure random sampling. And let's name P5 as Bohol province, and let's name P8 as Cebu province. So next step that we have here is that within each of these 2 provinces, select 20% of the towns either by pure random or systematic random sampling. So for example, in P5 in Bohol province, we have 47 towns. So 20% of 47 is 9.4. So we have to choose 9 provinces. And in Cebu, Cebu has 44 towns. So 20% of 44 is 8.8. So let's round it off to 9 towns. And the 9 towns that we can choose here in Bohol are Tagbilaran, Tagbilaran, Luway, Baclayon, Lobok, Lila, Duero, Hagna, Talibon, Sagbayan. So those are the 9 towns. So in Cebu, Damandaue, Oslo, what else? So I'm not that familiar of the towns in Cebu. Let's focus in Bohol. So after that, within each town selected, choose 20% of the barangays or barrios. So for example, in the town of Tagbilaran, we have here 15 barangays. So 20% of 15 is 3. So we only have to choose 3 barangays. 3 barangays, yes, 3 barangays. And so by pure random sampling, we were able to choose Barangay Bool, Barangay Cogon, Barangay Dao. And so we all know that in each barangay, there is only 1 elementary school that is found there. So for example, in Barangay Bool, there is Bool Elementary School. In Cogon, there is Cogon Elementary School. In Barangay Dao, there is Dao Elementary School. So since the elementary school is a final sampling unit, then the population in there can be stratified into teachers, students, parents, security guards. So that's those are the people that will be included as your sample. So that's the concept of cluster sampling. So its main advantage is that it is efficient. It is efficient in a way that it is organized. So as you can see, from the region down to the final sampling unit, which is our elementary schools. So it's very organized, diba? However, its main disadvantage is that it's reduced accuracy or reduced representativeness, because we all know that statistics or numbers aren't always right? And the data or the statistics that we can gather from LGUs, from census, or from the internet are not always updated. So we don't know that we are already calculating the 20% of section 1 in Barangay Bool, yet we don't know that some of the students there are already not studying. Maybe the teacher or the school record was able to give the researchers incorrect data, or unupdated ones. So that's it. So that's a main disadvantage of the cluster sampling. And now we move on to the guidelines for determining adequate sampling. So the first one that we have here is that smaller sample is enough when the population is more or less homogeneous and only the normal or average is desired to be known, while larger sample is needed when the differences are desired to be known. So when we say homogeneous, it means alike. So for example, if your population, if your study would like to involve civil engineering students as your participants, and you also want to know the level of difficulty of calculus among those civil engineering students, then you can only get smaller sample because you know that they are all civil engineering students. And the other characteristic which makes them alike is that they all have the subject calculus. Whereas larger sample is needed when the differences are desired to be known. So if you would like to know the level of difficulty of calculus, geometry, trigonometry, physics, and other subjects, so you need to have larger sample. Next one that we have here is that larger sample is needed when the population is more or less heterogeneous and only the typical or average is desired to be known, while smaller sample is sufficient when their differences are to be known. The third one that we have here is that the size of a sample varies inversely as the size of the population. The fourth one that we have here is that for a greater accuracy and reliability of results, a greater sample is desirable. So of course, if you want your study to be reliable, to be valid, you need to have larger sample because it has greater representativeness. The fifth one that we have here is that in biological and chemical experiments, the use of a few persons is more desirable to determine the reactions of humans to drugs and other substances. So if you're conducting biological and chemical experiments, you don't want to have the tendency to harm many people. So you should only have smaller sample because the reaction does not differ greatly. We are all humans. And of course, if we take for example, if someone would let us take 40 drugs, then of course later on we will feel hallucinations, and eventually we will become dizzy and those things that are related to, and those side effects are related to party drugs. So the next one we have here is that when the subjects are likely to be destroyed during the experiment, it is more feasible to use animals such as rats. So of course you don't want to harm other people when doing experiments. So of course you should use non-humans, especially rats. So in most experiments that we know, rats are being used as the subjects and not humans. So the last topic that I shall be discussing to you today is the steps in computing the sample of a size. So the steps that we have here are the following. First one, determine the size of the study population. So of course you need to know then how many people are there in the population, and you indicate this one in your scope and delimitation of the study. Second one is that decide on the margin of error. So margin of error measures accuracy, and when we say margin of error, it is the statistic which expresses a sampling error that being produced in the results of the survey. And the ideal margin of error is 3%, and your margin of error should not be higher than 5% because the lower the margin of error, the better. Third one is that use a formula, the Sloven's formula to be exact. So the Sloven's formula is used in getting this sample, in which, as you can see on your screen, small letter n which represents the size of the sample. Capital letter N represents the size of the population. And E, which represents the margin of error. So in a formula, capital letter N is over 1 plus capital letter N multiplied to the squared margin of error. Fourth one is that if the sampling is multi-stage or if the population is stratified, compute the sample proportion or percent by dividing the result in step number 3 by the population. The fifth one is that multiply the number of sampling units in each final sampling stratum by the rate percent to find the sample from each final sampling stratum. And the sixth one is that add the samples from all the final sampling strata to find the total sample. Next one is that we have here the 6 steps and of course an example, a sample situation. So let's read it first. Suppose an investigation of the teaching of science in the high schools of a region is to be conducted, in which the science teachers are to be made respondents. There are 2,243 teachers handling biological sciences, 1,406 handling chemical sciences, and 992 teachers handling physical sciences. So a total of 4,641 teachers. So the sampling procedure follows. Step 1, the population is 4,641. As you can see on your screen, the margin of error is to be used is 3%. And step 3, using the Sloven's formula, small letter n is equals the capital letter N, which is here the 4,641 over 1 plus 4,641 multiplied to the squared margin of error. And the answer of the product of 4,641 multiplied to the squared margin of error is 4.1769. And next one is that 4,641 over 5.1769 would give us the answer of 896.4825. So this may be rounded to 900 for convenience purposes. So the 900, which is the answer, is our sample. And step 4, the teachers are grouped into 3 categories according to the branch of science they are handling. So we use stratified sampling. So sample proportion is that we are going to, the example is using here is 20%. So the formula for this one is small letter n over the capital letter N, which is the size of a population. So this is the formula in getting the sample proportion. Diba, a while ago we were talking about 20% in all the examples. So in this, we can already know the formula in getting the sample proportion to be used in getting our sample in the population. So the 900 there is being divided by 4,641, and that would give us an answer of 0.1939. So in here we can see that the 20% that we were talking about earlier, the 20% that we would like to get in the population, this is already the formula in getting that 20%. So in getting that 20%, n is over, a small letter n is over capital letter N. So as you can see in your screen, 0.1939 may be rounded off to 0.20 or 20% for convenience of computation. So step 5 and 6 is are being illustrated in your screen, in the table, on the table you can see on your screen. So since teachers are being classified in their subject of specialization, such as biological sciences, chemical sciences, physical sciences. So they are stratified. And as you can see in the table, the number of biological sciences teachers are also being placed there, as well as the chemical sciences and as well as the physical sciences. So 20% of 2,243 is 449. 20% of 1,406 is 281. And 20% of 992 is 198. So you add all those sample and you get 928. So out of 4,641 population of teachers, you only get 928 as your sample. So that's those were the steps in computing this sample of a size. I hope you understand. And thank you for listening. Bye.